So that we have enough time at the end, which you guys were like, wait, time at the end, why? So that we have enough time at the end, we need to dive in. At the end, on that clean piece of paper that you have in front of you, which you should go ahead and put your name and date on, you will be writing me a message, kind of like what we did last time, but we're ratcheting up kind of the responsibility and expectations. You're going to write me a message for how you think you did, whether you think you showed mastery, progressing, you guys know the grading scale now, and why. So if you put yourself in the shoes of somebody that was trying to give you the feedback, I want you guys to understand how, because math is weird with mastery. And the new math curriculum is weird with mastery. I'm still learning it. So I'm kind of using you guys to help me figure this out. How do you think you did? Give me some insight. So not right now, but if you think, oh, I didn't do my homework well enough, or I didn't do my homework on time, and then I had some gaps and that led to how I did, or maybe that day I would just, other things were going on and I made some silly mistakes. Please don't call them stupid mistakes. But we all make silly mistakes sometimes. Things that we know better, like now that you look at it again, you're like, oh, yeah, duh. So we're going to talk about this for a few minutes, like 20, probably, at least. Then you guys are going to write me a message for how you think you did and why, like 3 to 5 sentences. Please try to have decent writing. I don't often cops in this class. I don't want to need to, but if you're turning in trash writing, I'm going to have to start to cops and care about those things. So please try to make it moderately decent writing. So, our test. Some of these questions were easier for people, some were more difficult. This one was pretty easy for most of us. We know that the map showed a scale of 1 inch equaling 60 miles, and especially now that we did the activity with Are We There Yet? Before Thanksgiving, I think a lot of us did just fine with this. You took the conversion factor and you said, well, if I have 2.5 inches, I just do my 60 times 2.5, or the multiplication the other way around. Some people set this up as an improper, 5/2 times 60 over 1. Some people showed this, we'll shift this down. Yeah, I don't want to lose it. Some people showed this, even having the units. They started by saying 5/2 inches or 2.5. Actually, I think the person who showed units actually did this. 2.5 inches over 1, which is kind of weird. We don't often put decimals and fractions, but that's fine. Times the conversion factor of 60 miles over 1 inch. And actually, let's go ahead and all write this down this way, because we want to get used to doing this for a very specific reason. When units are on top and on bottom, they cancel. So please show this, even if you have the right answer, most all of you, because I graded these. The right answer is 150 miles. But the biggest thing we want to get used to with conversion factors, because we'll start to do problems where you use multiple conversion factors, something times a conversion factor times another conversion factor times another conversion factor to cancel units, cancel units, cancel units. This unit that gets left alone becomes the answer unit. One.
It's like inches over, so like 2.5 over 1. What if the 1 was a mile?
So let's say this was seconds. Let's not make it the same thing. If this was miles, it would cancel. And then we can't really have a number without a unit. Like if we started with units, we have to have units. So that would be weird. But if this was seconds and there's miles on top, this would now become miles per second. Like your label can have a per involved in it. So like we're used to miles per hour, miles per, like, if there was another label on bottom, that other label, if it doesn't cancel, it would stay. But we don't have that right now, but very good question. If it doesn't cancel, it stays. Right?
So I solved mine with like a unit table.
Yeah.
Is that like wrong?
It's not wrong, but it's not really right, because we want to show multiplication with the conversion factor. So what Naya is saying is we can pretty easily build a table of inches, miles, and we can go, okay, 1 inch is 60 miles, which means 2 would be 120. We could go backwards and say 1/2 an inch is 30 miles. A few of us did this, like a few of you guys might be recognizing this. Then we say, okay, these together make 2.5, which must be 1/5. That's okay. That's good number sense, good reasoning, but it's not really working with the conversion factor. So this isn't wrong, but we're more looking for something with conversion factor. Other questions on this one? So I'm going to expect that all of us have this for 1, right? Nobody's got a blank paper for 1 right now. You've got written the work with the conversion factor. Number 3 got a lot of us. Number 3 and number 4 are the main reasons that we're going over this together. We might get to dive into the textbook today. One thing I always kind of chuckle myself at is how, as we get to more and more complicated math, the simple math seems to get harder. Like, not that it is more difficult, but harder for us to focus on. When I look at just this, you don't have to write this yet. But if I gave you this on a test, right, that's what I gave you. What do you do?
You do 8 subtract 6, which is 2, and then you do 2 plus 2.
Which gets you 4, right? Because we work left to right through problems when we're on the same step of PEMDAS, which inside this parentheses, addition and subtraction, is the same step of PEMDAS. Some of us don't feel bad about this because everybody makes this mistake occasionally. Added these first. You got 8. You did 8 minus 8, and you got 0, and that threw everything off. Your answer in that parentheses should be 4. In that parentheses. So, no. So your answer for A will be negative 18. Oh yeah, if you did it this way, we would get 0, which is not 4, which is not right. So we do not do that first. When we're working in the same step of the ladder, we go left to right, which you might need to remind yourself, which is totally fine. On your test, if you want to jot down, okay, PEMDAS actually looks like this. That could be a good reminder to your brain to go down the list and check things as you go. So now, please write this on your paper, even if you got it right. Might as well just write it with us. So please write the 2 parentheses 3 times 5 minus 8, parentheses minus 4 times. Go ahead and write that all. Then, parentheses has to be first. We already said we know what this parentheses becomes. But in my first parenthesis right here, what do we do first? 1. 3 times 5 gives us, that becomes 15 minus 8. So this will become 2 times 7 minus 4 times 2 times 4. What's going on between this 2 and this 4? Multiplication. What's going on between this 2 and this 7? Multiplication. Now we got to work left to right, guys. There's no exponents. Our parentheses aren't really parentheses. This is multiplying. This is multiplying. So 2 times 7? 14 minus, well, 4 times 2 times 4. I can just do it all together. 4 times 2 is 8. 8 times 4, 32. That's how we get to negative 18. B, I forget which was actually harder, A or B. B, the only thing that trapped a couple people is 3 with a little 2. That's a power, that's an exponent. What does that mean? What does that tell me to do, Alex?
That means how many times we need to multiply the big number by itself.
How many times we multiply with the base. So this is actually 3 times 3, which is 9. This becomes 12 divided by, sorry, my thing up here looks terrible, divided by 4 times 9, because we do that first. Then what do? Tyler?
You divide the 12 by the 4 because multiplication and division come the
Same step, right? Same step. So we work left to right. So 12 divided by 4, 3 times 9 now becomes 27. Question. Order of operations is tricky. It is easy to trip up on those. Questions. Guys, I'm taking this time because, one, this is really, really important. Right? Getting these gaps and these errors filled in right now is really important. So this 3-week span between Thanksgiving and Christmas, we're going to run as fast as we can, but I wanted to address these issues before we move forward. Also, it's Monday after a break, and nobody really wants to think very hard. So I wanted to kind of ease us back into things. So we're not just jerks trying to give you as much work as possible. I get it. Monday after a break is kind of poopy, so I thought we'd ease back into things. Why? Because this division happens first as we work left to right. So I have to compute that before I can do the multiplication. Does that make sense? Because make sure that on your paper you can read that that's division. Up on the screen it's hard to see. But that's 12 divided by 4. Well?
I was going to say, is it okay that, so in mine, because it was so small and didn't want to confuse myself, I did the division first, and then when it said 3 to the second power, I just put 3 in.
That's, so technically you have to square the 3 first. You can't divide before you do the exponent. Technically. Now sometimes you'll still get the same answer doing things a little bit differently, because the 12 divided by 3, or 12 divided by 4, does not affect the 3 squared. They're separate. So that's why, but technically, we got to square the 3 first. Ooh. Not to what? Oh, this is not 3 times 2. Yeah, that's the other mistake some people did. This is not 3 times 2.
I once did a whole math test.
Yeah.
At the very end, I realized that I was doing base times the...
Now, this probably got the most of anybody.
I gave up.
Now, hold on. We're going to solve this a couple different ways. I got 2 ways that I like, and both of them happened in this class. So, everybody's going to write this stuff down. Even if you got it right, and most of us, even if we got it right, weren't all the way there. So, on your test, I added some labels. This is an x squared, x, 1, 1. Now, one of my favorite solutions here, marked out 1, 1, 1, 1, 1, 1, 1, 1, 1. I can't really write out there 1. And they counted those and they said, okay, we got 10. 1, 1, 1, 1. 1, 1, 1, 1. Right? We got 10 ones, but that's not everything. Then they said, all right, this is x, and this is x, as you can see on the next page, because it's x squared, it's x by x. They said, okay, plus x, plus x. Here comes the part that makes you want to put your pencil in your eyeball. What? I mean, I'm not joking. This is tough. First off, we don't know what x is. Then we take x and we take a piece off of it.
We take 1 off of x.
We took 1 off of x. So that red length is x minus 1 and x minus 1, because there's one of those lengths right out here also. Now, if you wrote this, you're kind of right. So go ahead and please write that on your paper, because we all solved it different ways. I want to make sure we all have 2 ways of looking at this.
I have that in different.
Here's the problem that makes this not all the way right. This is really complicated, and we can clean it up. This is not wrong. It's just not all the way there. Every time I take away a 1, I can actually take away a 1, right? I've got 10 ones. I can't take away a 1 from an x because these are what we call non-like terms. All right, so x and x are like terms. They like each other. They'll party, they'll hang out, whatever. 1 and x, they can't, x is not countable. Some of us, and you drew a pretty good reason why, some of us tried to give x a value. You can't give x a value. It is not countable in this problem. So this minus 1 and this minus 1, I take 2 away from the 10. Now, if this bothers you with like showing it, you would first go ahead and say, okay, 10 plus x, plus if I can't do a parentheses, it disappears. So it becomes x minus 1 plus x minus 1. I can't do inside of here, so it disappears. 10 minus 1 gives me 8. X, and x. How many x's? 4. We have multiple of them. We show that with multiplication. That's your answer. If you want to really be mathematical and precise, put the variable value first. So you write it 4x plus 8. Now, another error that I saw, mainly on a problem past this, the next problem actually, when we say we have 4 x's, we could say we have x times 4. But that is not how mathematicians write it. Mathematicians, and you guys are all mathematicians right now, you're doing math. Mathematicians say how many you have before you say what it is. So I don't say I have x and I've got 4 of them. I say I have 4 x's. So while this is not wrong, this is how we actually write it, with the coefficient in front. So that's your perimeter, 4x plus 8. Questions on how we got to there? I'm going to show you another way to get there. Another way to get there, in my mind, I kind of think of as like,
good morning, Brady Cool, please stop by the office. Brady Cool, please stop by the office. Thank you.
I kind of think of it as like the sharing is caring method. So I have 10 ones, right? And we already said that these kind of long red sections are x minus a 1. So what if I take this one from over here and just move it in to make it a whole x? And I take this one over here and I move it in to make it a whole x. Now I don't have 2 of my 1s around the border. So how many 1s do I actually have now? 8. But now I can say, well, that's an x, that's an x, that's an x, that's an x. Sharing is caring. Makes it way easier. In your brain, you can geometrically scoot some stuff around. Say, well, that length here, I still travel that length, but I'm thinking about it right here as opposed to out there. Questions on that?
That's for area.
That's for perimeter still. Because I took the length out there, scooted it in. Now, if that confuses you, don't do it. But if you are a good geometric thinker, we all have our strengths. Algebra versus geometry. If you can visually make that shift, that works out. Now, area, hopefully you looked at number 4 to help you. You can just go through and say, I have an x squared tile. I have then an x and a 1 and a 1. This is not right. It's not wrong, but we got to simplify. We got to put things together. So, Booth.
X2 plus 2x. Oh no, it's x squared plus 2x plus 2.
That's your simplified area. If you want, you can say 1 x squared, but you don't need to. That's redundant. That's like saying 1 Will, 1 Oliver. You don't need to. Any questions on that? Area. Most people had the area right. Perimeter was a little iffy. In number 4, Hermione, playing with tiles. Now, I know this will probably excite you, but these plus minus tiles, where we're headed is a lot more deep understanding sort of modeling. Area tiles. Literally like the things in the test, the pictured items, we're going to start to work with these. This was a first intro to CPM. We kind of push you beyond where we are, and then we like to give you that intro. So I gave you some explanation here, right? This is x by x and 1 by 1 and 1 by x. There's a lot more tiles in there. It gets complicated. A lot of us did this well. The only issue that I saw was using the powers. When we look at writing an algebraic expression for what they tell you Hermione has, she has 3 large square tiles. Now, a couple of you guys did not give me algebraic. Algebraic means using numbers and symbols, not big plus big plus big plus skinny plus skinny. No, come on, that's like 3rd grade. Yeah, a couple people did that. Now, that is an expression. Don't get me wrong, that's a way to do it. That's not algebraic. So algebraically, on A, they tell you she's got 3 of the big square ones, so 3 x squareds. Because this is the name of the big square tile. Plus, she has 7 of the skinny ones, 7 x's. And some of you guys had parentheses, totally fine. And then 6 of the little square guys, and you had like 6 times 1, which really simplifies to 6, and that's totally fine. When we're naming, we're talking about area. I got some people that seem like they're trying not to look up here. I don't want to move you, but I will if I need to. Now, some people were trying to use how many they had as the power. We're going to work a lot more of powers this year. Well, let's really clearly understand right now. Powers give dimension. So, an x, if I measure this, this will make more sense. So I take papers home with this, right? So if I was going to try to build one of these, and I measure across it, that is a length. That is like an x. How long is it? If it's only 1 wide, say it's 1 inch wide. Now I know this is not 1 inch wide. Then if I say this is x by x, that's the area, which is the flat piece, has no thickness. It is just area. Then, when we look at x cubed, that would have to be it's x by x tall, and it makes a cube. Who plays Minecraft? It makes a cube, a block. X by x by x.
Literally the entire Minecraft world.
Yes, is all made of x cubes. Now, actually, it's probably countable. Their cubes, I'm sure, are countable. But we are not dealing with any powers above 2 right now. So this is volume. We're not dealing with that right now. It would have to be 3-dimensional. And then powers beyond that are things we can't see, but we'll get there to what it represents. So then Ron passes by and takes, so if you need to correct this, please do so. 2x squared. He takes 3 of the x tiles. And now, this was only asking for an expression to represent what Ron took. Yes, you understand what they're going for here. Hermione, Ron.
Where's Harry?
Where's So, Hermione now has, well, if he had 3. Now hold up, D is where a lot of us were kind of iffy. So, C, what she has left, she's got 1 of the x squareds. She's got 4 of the skinny rectangular ones. And 5 of the little square ones. A lot of us didn't do D correctly. Everyone read D real quick on your own. What? Yeah.
So you marked mine wrong because you thought I wasn't answering the question fully, but I did answer the question, but I just don't think you understood it.
Ooh, big words there. I just don't think you understood it, Mr. Hudson. No,
Mr. Hudson.
No, you didn't show it.
How? Because
Showing what Hermione started with, what was removed, and then what was left. So we're gonna go over this. Give me a second.
Mr. Hudson.
Hold on. D very specifically. Write the whole thing being excessively detailed. We need a start. We need what got taken. And then what we have left. If we're going to technically show this the way that we would with an expression, we start with 3x squared plus 7x plus 6. Take away 2x squared plus 3x plus 1. Now, some of you said like minus 2x squared minus 3x, like you wrote it out like that. That's okay. But really, we were looking for like quantities. We start with a quantity, we take away a quantity. Then we're left with, so we just put equals the expression at the end. This was not wanting you to condense everything. It was wanting you to show everything out. So x squared plus 4x plus 5. Yeah. Okay. Right. D wanted you to show everything out though. It wanted to like, so not just, yeah, it built it for you. All right, we got to keep moving on because I'm running out of time way too quickly. I did not continue providing feedback because I had at this point decided we're going to go over this together. So you are not marking on your test, but you are writing, if you have any mistakes or anything, write it on the blank piece of, well, what is now no longer blank, but the piece of paper that you have out. So, is the relationship between pounds of pistachios and price proportional? Anyone able to help me out? Nina?
It is.
It is. What do you think? What is that relationship?
Well, if you buy no pistachios, you pay no money.
No pistachios is no money.
So
What about what they gave you?
And the price goes evenly up every time.
Yeah, if we look at price, most of the time in America we talk about price per amount. Don't ask me, well, pounds is LB because Libras used to be known as Libras. Yeah, it's literally why pounds is abbreviated LB. 796 divided by 2. What we're asking is this equal to 199 divided by a half? Annie?
What I did, and I got the right answer.
Yeah.
But I did 1/2 pound for 199, and that times 4
Yeah.
would equal 796.
Yep. Love it. Love it. Another way we can do this that I saw in a couple people's papers, all because I don't provide feedback doesn't mean I didn't look at it. I look at everybody's papers before I ever start grading. Just like to look at them, and on a plane it's really hard to rate, so I was just looking at your papers. This, if I got it to the price per pound, would be what? $3.98. So then if I divide again Then I get that half pound, which is the $1.99. I can kind of work my way down. I saw a couple of you guys do that. Multiple ways we can do this. Yeah.
Were you supposed to add all the numbers? Because I just said it went up evenly every time.
There wasn't like a what you were supposed to do. Just show how you figured out whether it was. It is proportional. So we know it is proportional. It's how you show it. So then, I gotta hurry up. Unit price is the price of one. We've talked about this a little bit. We'll continue to practice this year. Unit price is price per one. 1 pound, $3.98. There's your unit price. Then next week, Murphy plans by 5 pounds. You can compute that. Take your unit rate, multiply by 5. Who's got my answer here? Almost $10, Nia. What do you got? How much? 1990. Sorry, yeah, not almost 10, almost 20, because it's about $2 a pound. Almost. Now in my head, not $2 a pound, $2 a half pound. It's about $4 a pound. In my head, forget about the 2 pennies. It's $4 a pound. If you, on a math test for me, reason out, and you say, well, this is approximately $4 a pound. Approximately, it would be 20. That's okay. If you reason out and you do some approximate math, but I need to make sure that you're able to do the exact math. So in my head, I'd be like, yeah, times 5 and 20. I'm not going to care about the pennies. Because if I take $20, I've got enough money. And 8 was, I'm just going to show you. Okay, that was 5. But, yeah, 6, sorry, man, I'm just going to show you. So 6,
Really bad diagram.
now, obviously, Tess's sketch is kind of lame here, but
Proportional.
here's what your drawing should have been. If you did what I advised and started at the corner here, we go 4, then we have the bed, which is 3 wide, and then we have 3 open beside the bed. Running this way, how many blocks? 12. Up to the dresser or something like that, there were 5 blocks. Then this is 4 wide, leaving 1 gap. It is, yeah, right? That's a very long bed. He must be tall.
Tall and skinny.
Isn't it a girl?
Yeah, whatever.
I don't
Gender is negligible. Who cares about gender these days?
I do want to tackle.
I am a No,
I said I do.
Oh, Tess could be.
No, it says all her
Okay, I'm trying to justify what I already said. Any questions on the drawing? All right, we did not get to every single problem, but with the last 5 minutes, or slightly less than 5 minutes, I need you to write me a message on that sheet of paper that you've been out working on. How do you think you did and why? If you just say, I think I mastered, you will get a not progressing. You must explain. How do you think you did and why?